In this video, we'll talk about velocity, distance, and acceleration. I will start with the very basic example, and slowly we will go to the higher level and we'll use calculus to do the same calculations. So let me start. So suppose if I have a velocity of 60 miles per hour, right? And I ask you if the time is 2 hours, how will you calculate the distance traveled? So in this case, you don't even need to open a book. Anyone who have never read about velocity or distance can do this calculation because most of us travel. So here what we'll do is we'll just take 60 miles per hour and we'll multiply it with 2 hours. Now you can see the units cancel out and the answer is 120 miles. Right? Same way, if we have the same problem where we are given t is equal to 2 hours and distance is equal to 120 miles, right? So if we are given this two data points, then we can calculate velocity as distance divided by delta t, where delta t is 2 hours, so distance is 120 miles divided by 2 hours, and that will give us 60 miles per hour, right? So this is the velocity. So basically velocity is equal to change in distance per unit time, right? And the distance itself could be also displacement. So right now we are not talking about the vectors, but there could be scenarios where the distance and the displacements will be different numbers, and we'll talk about that in the later stage, right? So now from here, let me look at the graphical representation. This was very easy example, but this example was important because now we can look at the graphical representation of the same. So now if I'm looking here, this is the time and this is velocity. Then I started at 60. So I'll say this is 60 miles per hour and this is 0 hour, and we go from here to here. The velocity is constant, and now this is 2 hour, right? So if I draw this plot, the velocity plot will look like this. The velocity is not changing with time, going from 0 to 2, right? Now in this case, if this is the line, the area under this line, so if I look at the area under this line, this will be this, right? So this area under the line will be equal to, so this is our 60 and this is our 2, right? So area under the line, area under curve is equal to 60 miles per hour multiplied by 2 hour. So that gives me 120 miles. So basically the area under the curve on a velocity time plot will give us the distance, right? So this is the important thing to understand because that will allow us to do some complicated calculations. Now I'll start with another example. Now suppose if we have a car, right, and the car right now is at velocity is equal to 0, so the car is not moving, and eventually we start the car, and now it takes us 2 minutes to reach speed of 60 miles per hour, right? So calculate distance travel. So how will you do that? Because here the velocity is not constant, it's going from 0 to 60, and it taking 2 minutes. So how much distance will be traveled in this 2 minutes? So for this, what we can do is we can again go to the graphical representation. So here I am looking at velocity and this is time, and I started at 0. So this is our 0. So there was no velocity and time was 0. And eventually as the time progressed, the velocity kept increasing, right? And then it reached 60. So now this is 60 and this is 2 minutes, right? So now to calculate the distance traveled, all I have to do is take the area under this plot or under this curve, right? So here the area will be equal to, but because this is a triangle, and this side is 60 miles per hour, that is equal to 1 mile per minute, right? And this one is equal to 2 minutes, right? So the area will be equal to half into base into height. That's the area of a triangle, right? So here that will be equal to half multiply by 2 and multiply by 1 mile per hour. And the unit for the 2 is minutes. And sorry, this is not hour, this is also minute, right? So the minutes will cancel out, 2 will cancel out, and the answer will be equal to 1 mile. So you will travel 1 mile if you accelerate from 0 to 60 in 2 minutes. So that is the answer, right? So this is how the graphical representation is important. And in the next video, we'll talk about how we can do more complicated calculation using the calculus.